All right, go ahead and refresh just to make sure I'm still logged in. All right, so what you're going to see on the screen here is a environment that we've got for the Digital Twin Studio. Now, keep in mind that the Digital Twin Studio is actually a part of the user portal. It does have access control, so it is limited to specific users that you may actually choose. But importantly, it's really a part of the user portal, right? Which means that your teams, your audiences, your right folks can actually use this and very quickly and easily view or verify how the model is behaving in terms of visualizations, etc., in the user portal on a live environment as well. But really, in the digital twin studio, it's built to provide, if you think back to our workflow, provide an environment to really help with the asset model definition, to help you with data connectivity, and then the analytic build and deployment process as well. And so really, you've got, several options here for it in terms of building the asset model and then connecting to your data sources, but really outside the scope of today. And so today, what I really want to focus on is the analytic model building process. And that's where we have the AI Studio. Now, typically in the AI Studio, you have a few different use cases or purposes that you can actually work with over here. So we have something called projects, and an AI project is essentially a logical grouping for you to have all of the models that you want to build for, let's say, the same asset or a similar asset, given the data set, given the pre-processing steps that you might want to do. Again, so it's just a way of how you can categorize or really organize your model building process in terms of the experiments that you would be running to iterate along with the different runs or the model runs that you would have to build these different models as well. Then, of course, we have data sets wherein you can actually import data from the platform. So let me just go into this. You can import data from the platform. Let's say you've already deployed it. You have data that you have available and you'd like to use that, or you can import data as a file. You can view some of the analytics that are available already, right? So you could have some models that you build, certain inputs, certain outputs as well. And then, of course, we've got FMEAs. Now, a failure modes and effects analysis template is essentially what provides the context to the AI model based on your production process, your assets, and your equipments and your know-how, right? Now, the FMEA is quite typical in the manufacturing environment, and it's, again, quite similar to how it's built here. You have the causes and failure modes really categorized and quantified with a risk priority number, along with other aspects. You can also look at the different types of tags that you would be using or would want to use when you're building the model. And then, of course, you've got certain causes, recommendations, and then how you can actually weigh this as well in terms of how you can tweak the FMEA to really provide that context in a way that makes the most sense to you. So really, in this case, it's trying to provide a machine reasoning addition to the machine learning process that an AI model does provide. All right, so let me first start with ingesting some data, and I'll upload a data set just so we can get started into really taking steps to understanding how that model is built as well, right? So I have two data sets. I will show you what this data looks like. I'm just going to upload it for now. But again, I will show you, we will explore it, we will visualize it, and we will take a look at it just so you have a better idea of it. So I'll say DTS webinar August 23. And again, I've just imported a training data set, which you will see right here. Let's go ahead and actually view what this data set looks like. And so really, this is how the data looks. So you've got time series data for several different columns or features within this. Each feature, of course, has a data point. In some cases, of course, you can see that there is some data that could be missing. Perhaps it's close to zero values, etc. But really, you've got one data set that you do have available. Now, really, what you can do is view some statistical summary information. So things like mean, median, mode, your min, max, etc. as well, right? So really, in this case, you see that we have about 1,000 rows of data in this data set. And then really you can start to visualize it as well. So what we'll do is we will just go ahead and select a few, let's say 6, right? We got these line charts. So you can again view how this data is actually trending, right? You can actually view it in a single chart as well to again understand, how certain, tags or features are actually behaving, versus some of the others. You have histograms that you can do to really understand the distribution in terms of, what the skew perhaps might be and how you may want to handle it when it comes to pre-processing. You can also very easily and quickly look at the correlations, of course, being, -1 to 1, that you can look at in terms of the negative to the positive correlations. And then, of course, you can understand the outliers as well. So again, in this case, you can see that this feature has several outliers versus some of the others just has much wider range versus some that do have a smaller range as well. So really neat tool, neat visualization option that you do have, and you can actually go ahead and just add in as many as you'd like, to really help you visualize some of that data, right? So that was one of the data sets. Like I mentioned earlier as well, what we're really always looking to do is create a training data set and a testing data set. Now, the training data set is what we're going to use to actually build the model. The test data set or the scoring data set is what we will use to actually verify how the model is actually performing based on information that we have, right? Just to again ensure that the model is providing a output which is in line with what our expectations are as well. So I'll go back into the statistics, the summary statistics. So in here you can see that we've got 500 rows of data, which means we've got a smaller data set in here, because if you look back, each row was a single timestamp of data. And so you've got 500 rows of data that we're actually going to test our model that we build on as well. All right, so let's do this. We'll go ahead and create a new project. We'll say today we're doing the DTS webinar. Oops. We go in August. And same thing there. And we go ahead and create a project. Now, we go ahead and look at this project itself. And like I mentioned, this project is a logical grouping for how you may want to manage your experiments. So in this case, we'll say this is a ball mill anomaly detection model that we're going to try to build. Anomaly detection is the first one that we're going to try to build as well. And so really that's where we have this grouping of experiments, right? Now within one experiment, which in this case is the ball mill anomaly detection, the first thing, of course, that I would want to do is actually select the FMEA rule set. So, right, this was one of the templates that we do have available. But of course, you can always add in your own. You can configure or customize the FMEA as well to actually tweak it and then have it available for you to use as part of this digital twin studio. Now, the training data set, and that's the first one that we will use. Right, this was the first one. That's the training data set. This is the same input features that we saw. So it was the same, I believe, 14 features that we did have, along with a scoring or a testing data set as well, right? So we go ahead and upload that. And right, so this is really how it looks. We've got the same set of features. We've now configured what we would like to use for this experiment. Now, really in this next step, right, what we're going to do is what we call creating a model run. Now, in a model run, you can have several model runs that you may want, and you can actually do this in two different ways. Now, we look at the first step, which is a little more, I would say, manual in nature, or single or singular. But then, of course, I will show you how to create a model very simply, just using a configuration file as well. All right, so in this case, we've got this model, and really the first step again, going back to the workflows that we just saw, the steps that we just walked through, that first step, once you have data availability, is in pre-processing the data as well. You can choose to skip pre-processing. I don't want to do that, but we are going to, again, pre-process this data, right? So again, in this case, what I can do is just go ahead and at least visually show you what this pre-processing data looks like based on the certain settings that I do have here. But again, I will tweak this around, and we can then take a look and see how this data set actually looks once it's been pre-processed. These are the different columns that we do have available, and you'd have your visualization options. So again, in this case, there is just a little bit of pre-processing. So right, up front, really no difference in the raw versus pre-processed, because we've not selected to impute any missing data. We've not decided to remove any outliers. So essentially, the data is as is. As we were looking through the data set, we didn't see any missing values either. And so again, it's not actually dropped any rows or columns. So again, no change really to the raw and pre-processed data that you do see here. However, though, of course, you could choose to oops, yeah. So you could choose to impute certain data. Maybe you want to use, one of the outlier methods as well, if you'd like to. But again, I'm just gonna, just choose to impute data. But again, I'm quite sure there is no data to be imputed, because really all of that data does exist, right? And exactly, that's exactly what I expected as well, right? So again, this is the pre-processing step for your training data set. I am okay with this, and then I can go to the next step, which again, in this case, is going to help me or prompt me to configure what those parameters are, in terms of how I want to configure, or what algorithms I want to use. So you have several options in here. So you have the autoencoder. You can use your KNN, which is a K nearest neighbor, K nearest neighbor method, or you can use, again, the PCA as well. You can actually configure this in a few different ways. At least this is what's available immediately in the UI as well for you to do. Then, of course, you'd go through pre-processing, and now this is going to be for the pre-processing data. Similar options that you do have here in terms of imputing data, removing outliers. Perhaps you want to select a shorter or a smaller time range. You could actually do that as well. But again, I'm not going to make any change to that. Really, I just want to see how the raw and pre-processed data looks, which again, in this case, I would suspect it to be the same. And that's exactly how it is as well, right? So this is really how the data looks. I am satisfied with it. I don't want to change too much. Really, in this case, I'm just trying to show you how the Digital Twin Studio is actually working in terms of the steps and the options you do have available. Now, when it comes to actually testing, right, or scoring, there are several parameters that you do have in terms of the output and how the output is going to be handled. Now, most typically, when with anomaly detection, you really would want to configure it for certain alerts that you may want to generate. And so really, in this case, you're given several options to configure the alert parameters, in this case. So for example, you could have a threshold that you could set for certain alert levels. Perhaps there is a silent period you may want to use. And again, in this case, if you're not sure, you can always hover over what that value is or what that actually means. And so you have those options. But really, you can configure how you would want your alerts to be generated as well. And so you can actually imagine where you have several tweaks that you may make to this. But once you're ready, once you've actually looked through the pre-processing steps for training as well as testing, you can come through and then actually say the ball mill anomaly detection run one. This is the first run that I am going to build, and I'll go ahead and actually run this, and I'll show you how it looks now. So while this is again going to go through the process of the model being trained, um, and then getting ready for it to be tested, we can actually just quickly view what the other option is that you do have in terms of viewing the configuration file as well. So let me show you what that looks like first. So I will show you what this um, file looks like. Oops. I will upload this first, and then I'll show you very quickly what the file looks like. And so you have the option again to actually download a sample file as well, but we'll go ahead and upload it. Right, so the file that I just uploaded, let me open that for you so you can take a look at it. Here are the different options that we do have that we've essentially just created and entered in using a YAML file. Now, this configuration file, for those folks that are a little more inclined to use, certain or more comfortable with code or with data science, they can simply create a file like this. Make sure that they put in the values that they'd like to see for pre-processing for the training set, testing set as well as some of the parameters that you may want for training and testing. So very similar to what I just showed you when it came to training and testing as well. So you could actually upload that file, saves you the step of going through the UI if again you're more comfortable with it. But we'll go ahead and right. So go ahead, run this as well, just so you can actually see how it is actually done. And great. So in this case, we have the first model which was run one, right, that we actually created, and we have that available. Now, in this case, you can actually view it. So that's exactly what we will do, or you can actually choose to duplicate it as well. And now the reason to do that is you can imagine between these two runs, I could have had different parameters that I may want or choose to have with training or testing that perhaps would have or could have been different options I may have wanted to use with pre-processing for the training and testing data set to really just tweak the model that I'm building slightly just to compare it with that same data set and really understand what the differences are, right? So again, in this case, we'll take a look at the first model that we do have and that we have built. And let's see what that actually looks like. So we have one alert that was generated. In this case, we have the alert level that was generated. So again, if you think about the thresholds that we had set, there would be causes and recommendations. Again, this is what would be coming in from the FMEA as well. So you can always tweak that around. In this case, there wasn't anything that was identified, but then you get the contributing factors as well. And so really in this case, you're able to very clearly tell that there are the top two tags that contribute the most to this specific alert and how they're actually trending over time as well. So you can actually view it to again verify that the result that you're seeing on this page is in line with what your expectation is with the model that you built. And if it is able to detect those faults or those issues that did actually surface up during the time period when that training data set was collected as well. And so again, you do have the option to actually view this. I can always close out of this. Let's just make sure that we have the run available, right? So in this case, we have this run available to us as well. And let's see if this is any different, right? So we had the current and power. So again, very similar output. The only difference being, I believe, that this is just a slightly more higher contributors to this alert that we have as well. But again, we'll go back to the first run because really now what I'd like to do is show you what you can do next, right? So a couple of different options. You could either choose to retrain or retest this model, which means you could essentially go back and tweak the parameters that you've used. Let's say retrain, you could tweak the parameters you've used for pre-processing and training, or for training, testing, pre-processing, and testing parameters as well. But again, in this case, I'm not going to do that. I'm going to assume this is exactly the model I want to use and that I actually want to deploy as well. Now, in this case, you have a couple of different options. Keep in mind, right, that when you're actually building a model for the first time, you would actually want to obviously create a new deployment for it, which means that you would actually want to make it live for the first time. Or going forward, when you're retraining and then retesting your data, perhaps you've got new data that you want to ingest and use to tweak the model. You could actually use the same model to replace an existing analytic as well. I could just very quickly show you what that looks like. So it's quite straightforward. You'll be able to select a model and actually just choose to replace choose to replace this specific deployment. But again, I'm not going to do that because really what I want to show you is how you can actually use this to create a new model and then deploy it as well. Now, in this case, what you did see, hopefully in the loader text, was a really helpful feature, we believe, to help you with speeding through how you're able to deploy the model directly. Now, what it said is the automatic feature is actually trying to match the features that we have in the data set to an asset model that we've got with certain tags or channels that we have defined as part of that asset as well, which means that the model is detecting that, hey, this is the model that you're trying to use with this specific asset. And I did recognize that you do have these three features from your data set matching exactly to a asset that you have, which in this case is ball mill, and the tag being ball power, right? So you do have three of these. So you do have three of these tags or interfaces which are actually mapping, which really form part of the input, which you could obviously go ahead and actually select it. So, for example, in this case, I do know that this is the. There we go. Just search for it. Yeah. So floating, right? So you do have, yeah, this is on, right? So yeah, so you'd be able to select essentially oops, I've mistyped there, but essentially you'd be able to choose the right channel to map to the input interface that you have used in this model specifically, right? Now, once you've actually done this mapping, you would also be able to select the unit family as well, right? So in this case, you can select the different. Sorry, there just seems to be a lag at my end. Apologies for it. But again, right, so you do have the ball mill asset that was identified. You have each of these individual channels that were made available. And then, of course, you've got the different unit families that you can use as well. And all of these are typically mapping to certain inputs of that model. Of course, you do want to map it to an output, which in this case, it's a single output that we're generating from the anomaly detection model, which in this case would be the anomaly score. And again, you would be able to map this or match this to a specific output channel for that specific asset as well. And then again, you could go ahead and actually use that at several different points, perhaps to calculate certain values, to provide alerts to you. Perhaps you want to use it to calculate a health score. Again, just different examples for how you may choose to use and use the output from a model that you have actually deployed. But once you've actually selected it, let's say I did have all of the inputs mapped out as well, I would then be able to go in and just put in certain parameters in terms of certain minimums or maximums and thresholds that I may want to have, and then ultimately verify it before I choose to deploy as well. I'm not going to go through each of those steps right now. I think it's fairly hopefully clear now that we've gone through with how the model's built in terms of pre-processing steps for training, as well as the parameters or algorithms you may want to use and the inputs you may want to give to that as well for training as well as for testing as well. And then really once you've got or verified the results of each model that you build from each run, choosing that appropriate model that you want to use, and then ultimately deploying it in a very quick and easy way as well. So this is really how you can go through the model building process. Again, hopefully it was clear enough to understand how you're starting off with importing your data sets, pre-process or building out or using the organizational structure that we do have of a project, experiment, and a run to then have multi-threaded runs that you could actually use and deploy to use and build as well, which off which you could then choose to deploy just one of them, right?